Welcome to the latest episode of the MFG Radio Network's Manufacturing Matters, where industry experts take deep dives into the latest technologies you need to consider to keep manufacturing moving.
Hello, and welcome to Balancing Operations, Complexities of Aviation Manufacturing and Supply Chain Management, brought to you by Aerospace Manufacturing and Design Magazine and Cornerstone Consulting Organization. I'm Eric Brothers, editor for the magazine and the webinar moderator. Modern aviation manufacturing is improving cycle times, providing systems rather than components, and working to resolve persistent supply chain issues. Introduce the complexity of regulation where everything must be approved by the FAA, and the supply chain management plot thickens. Aviation is seeing advances that could disrupt familiar supply chain patterns, which our guests will examine. First, a few words about our presenters. Bill Currents, president and managing partner at Cornerstone Consulting Organization, is an Army veteran who is passionate about sustainability in business and communities. He's the founder of CCO and has more than 25 years of leadership experience in executive sales, manufacturing, financial, supply chain, and engineering roles across industries spanning 5 continents. A financial and business development executive, Bill has led operations ranging from small, single plant sites to multinational divisions. Mary Blair, executive vice president, global material planning and logistics, training, is an accomplished supply chain executive. Blair brings to her role more than 25 years of leadership experience in strategic procurement and supply chain on a global basis. She has led transforming initiatives in the areas of procurement, logistics, and supplier quality, and has a strong track record of building winning teams. Steve Nolan is Cornerstone Consulting Organization's Vice President of Operations for a diverse group of clients, including aviation, transportation, and heavy equipment. Most recently, he was Director of Operations for Meggitt, overseeing consolidation of facilities from 56 to 34 sites while working with OEM customers and regulatory authorities for approval. Career highlights include Eclipse Aviation in Albuquerque, New Mexico, where he was instrumental in increasing production from 3 aircraft per month to 1 per day. Steve holds 2 U.S. and multiple European patents and was the recipient of the Henry Ford Technology Award in 1996. Before we begin, we'd like to thank our Manufacturing Group webinar series sponsors. ISCAR is the largest of the 15 companies comprising IMC, International Metalworking Companies, and has been a leader for nearly 70 years in the development of a dynamic and comprehensive line of innovative precision carbide metalworking tools. They have developed industry-specific solutions to optimize productivity. They understand the unique requirements of each industry and continually improve and introduce new ideas for machining intelligently. Renishaw is a global leader in developing technology that supports manufacturing process control. Renishaw offers an advanced range of calibration, measurement, positioning, and inspection solutions. Specified by leading OEMs around the world, Renishaw encoders, calibration, and measurement systems enable superior process control down to nanometer and picometer levels. We'd also like to thank this webinar sponsors. FPT, founded in 1969, is an Italian machine manufacturer specializing in the production of vertical and horizontal milling, boring, turning, and friction stir welding machines. Having produced over 4,500 machines, FPT is one of the largest machine tool builders in the world. To uphold the highest quality, precision, and deliveries, FPT prides itself on producing most of the components used on its machines in FPT's 2 million square foot state-of-the-art production facility. Due to its unique flexible machine building methodology, FPT is able to serve a variety of industries from aerospace, die and mold, space, power generation, and general fabrication. SMW Autoblock is a global leader of the highest quality work holding, clamping, and tooling solutions. Its world-class products guarantee superior precision and repeatability, along with dedicated service and support. The organization strives to achieve a deeper understanding of customers' needs to provide products and services geared towards specific customer applications, maintaining long-term, mutually beneficial partnerships to enhance machine tools and drive modern manufacturing. Tata Technologies, a leader in product engineering services, caters to the global manufacturing industry, enabling ambitious manufacturing companies to design and build better products. This includes supplying PLM, CAD, CAM, Manufacturing Operation Management, or MOM, and Manufacturing Execution System, MES, products to industry. Tata Technologies takes on the challenges of tomorrow by providing cutting-edge solutions to engineer a better world. They help the world drive, fly, build, and farm by enabling their customers to produce better products. Welcome, Mary, Steve.
Thank you, Eric. So the conversation we're going to have here, it will be at the beginning a little less hard industrial engineering and just recognizing what's happening in aviation and aerospace, and a little bit more deep into it. We'll get into some of the conversations that we need to have about a highly regulated supply chain and basically a slow moving processing process for aircraft, not running at rates like an automotive company does, but still wanting to get the efficient operations. And how do you balance that, and how do you manage the demand through to delivery to the customer? So Mary and I are in the conversation here. Mary will handle most of the supply chain discussions. I will handle most of the manufacturing and operations type discussions. Okay, so from an industrialization perspective, let's just look back in history at some key points that have occurred in history. So in the 1800s, in 1700s, if you woke up, the steam engine would have come out and would have been helping drive the Industrial Revolution. In the 1800 railways and steamboat improved transportation. 1870s, you can see the telephone and telegraph and electricity as a utility were released. 1900s, automotive transport and the beginning of aviation. 1920s, the first rockets started to appear. Computer spaceflight followed. So we have started on a journey of information and communication as a species and development as a species, but primarily in all of this, the world was two-dimensional. And right now, it's really cool. We're on the cusp of a major change to move towards a three-dimensional world for the average person, with all the advances that are going on in aviation. And so we'll talk a little bit about that, so that everyone's up to speed on what kind of advances are happening in very general terms. And then we'll talk about how that specifically relates to manufacturing and supply chain. So
Steve, before we go on, let me just comment on this for a second. So with the new product development and all the churns that's likely to occur in these companies as they shake out, this is going to be really difficult for the supply base to manage. The suppliers are struggling today to really meet the increased demand and really to touch on the advanced technology requirements. And as you're going to speak about later, regulations. The supply chain culture right now will need to change. As you had indicated earlier, this is not automotive. The culture will need to be able to manage not only value, but now innovation and volatility.
So let's look at some of the advances in aviation. I think most of you are hearing the conversation in general terms about low-cost fuel solutions and sustainability. There are great advances going on with the GE90 engine, released and rolling through all the fleet. There are future advances in that Airbus have committed to delivering a hydrogen-based system by 2035, which will in itself change the engines and the structures associated with that of most of the middle-level fleet across the companies. Personal and urban mobility solutions, it is starting off with significant work associated with taxis and replacing taxis from airports. United, Archer, now Stellantis are having relationships with each other and building up commercial connections, so that when you arrive in an airport in the future, you'll be ferried to your location without ever touching the ground and going through the difficult traffic environments in dense cities. Electric vehicle takeoff and landing systems will have huge import to transportation, be a major disruptor to the helicopter industry. So in counting the number of these systems, I stopped at 56. There's over hundreds of companies working to develop solutions to deliver aviation-based transport, which will ultimately lead to personal transport solutions coming out, so that the automotive industry itself will actually be threatened. In addition to this, there's a lot of old thinking that's been looked at again. Boeing have a relationship with NASA at the moment, looking at an equivalent to a biplane solution to maximize the lift of the system. And there's a revision to the 1980 CFM engine being looked at because of the advances in composites, which gives a basically propeller-based takeoff solution followed by a jet in the aircraft during the aircraft flying mode. So in essence, huge changes in the actual infrastructure that's happening. Within the next 10 years, this is all going to happen in a very short time scale. By the time 2035 comes around, the way we get around and do things will be different. Okay. Advances in actually aerospace itself. So in addition to the actions that are going on in aviation, the frequency of takeoff is phenomenal. If you go and look on YouTube, there's videos of Cape Canaveral where you see the takeoff rate going to, I think in the last month, there was one day where there were 3 rocket launches simultaneously. So that generates a whole new set of business, people to make the tools and equipment that it takes to make the rockets at that kind of frequency, people to build the rockets, manufacturing systems to do so, and moving ultimately towards personal aerospace transportation and hotels. A lot of this, as you know, has looked like fantasy in the future. If you'd looked about 7 years ago, you would have thought it was fantastical, but this is coming. People are working on these activities. I'm currently in a company helping them lean out their systems so that they can build equipment for rockets, and orders are coming in for multiple rockets in a sequence. And the industry, really, this is a huge new sector of industry, which is going to get much larger as we go forward. So on top of this, geopolitical influences are driving from a US basis reshoring and expansion in Mexico. So Mexico has been very active in aviation and advancing over years. The university in Querétaro in Mexico has a large aviation and aerospace program. Graduates are now well through the system and going out. GE has a 1,600 engineering center based in Querétaro for aviation and aerospace activities. So even the engineering is becoming less Eurocentric and less US centric, and is starting to spread out. The influences of companies in the Middle East and the work going on there in terms of personal mobility and other activities, the influences of China with their own aircraft carrier company at the moment, and the fact that in the last 2 weeks they released the first personal mobility vehicle that you can actually purchase. This will have huge implications for the supply chain. So Mary, do you want to comment on this?
Yeah, so outside of the legacy solutions, these new companies can just go right to the location at the start. I see the biggest issues with batteries here. Archer has teamed up with Stellantis to get access to their manufacturing know-how and scalability, but also to get the batteries. The growth in this area will escalate the supply chain constraints. Our electrical vehicle clients see it every day today and are struggling with keeping up with demand.
So on top of this, we have an aging workforce in aviation and aerospace. For those of you in the industry, just look around you. In the companies that I'm in at the moment, I'm seeing of the order of 40% of the people that I see are 55 and older. So the industry as a whole is going to have to make very significant changes associated with feeding new people into the system so that they can start to deliver solutions for the new technical challenge that will happen in the future. Okay.
So I would like to comment on science, technology, engineering, and mathematics STEMs. What we're seeing is fewer people than ever are getting into STEMs, which is also causing a huge workforce constraint. As we go forward and we talk about the regulations and we look at talent and skill set, this is becoming a bigger issue every day, especially in the supply chain discipline.
Technological advances. So composites in aviation have been here for basically 30 years. There are multiple solutions now going out, being deployed within systems. I've personally been involved in composites within jet engine systems and actually within body structures themselves. The advances over the last 15 years are astounding. Integrating composites with metal systems and fastening systems, and then composite machining is going to continue to develop as we go forward. Additive manufacturing is really, in my opinion, at this stage, a little still in the birth stages, given the highly regulated industry. But huge investment is going on into this, so this will not stay at this state for long. Additive manufacturing will become a much more significant component, and in a regulated industry where it's even hard to change from one supplier to another, how to control the variables associated with additive manufacturing and part printing will be interesting in the future, particularly in the area of safety components. Can automation help here in this highly regulated environment? Airbus have been riveting and fastening systems for years. Automated friction stir welding systems on the structure of an aircraft are huge. Automated testing within engine valves and other activities like that have advanced dramatically in the last 15 or 20 years. So you know, the standards of manufacturing excellence that are going forward here and the use of advanced technologies will drive the system more effectively. But when you get down to it, building an aircraft is not like building a car or a washing machine. The cycle times are slow, and they don't lend themselves readily to standard work definition at a minute scale. So within seconds as opposed to minutes. Cycle times are minutes and hours. So, for example, at a customer currently engaged in, we're bringing in a training expert to help an aging workforce be able to better manage understanding how to deliver the product within a structured time so that we know and have stable and predictable production. So taking an aging workforce, which really doesn't have the skill of laying out a schedule and then sticking to it and conforming it to it. And so that we start to, as the volumes increase with these products, get more stable production so that we can continue to see the demand being delivered within the times that are required.
So, Steve, just a question on automation, and I think this is good discussion amongst the panel. You talk about automation and technologies, but you earlier spoke about controls and robotics that are going to be needed. How do you think that controls and robotics will be able to cope with the demand increases that we're seeing today?
So the OE suppliers of the control systems, even though there's been a fairly major reduction in the number of control suppliers, probably about 10 years ago to significant 2 or 3, the actual control systems companies are scaling up to be able to provide more product. Anyone who's tried to buy a control system at the moment will realize it's 48 to 54 weeks for delivery, which doesn't lend itself to rapid delivery of equipment to build a product or run a production line. Robotic suppliers are working extensively to increase the capacity. I was in Detroit, Michigan yesterday, and Fanuc, for example, are opening up a huge, looks like 500,000 square foot facility on the side of the road there so that they can increase the robot expansion. And the systems are easier and easier to use and train operators in how to use them, and take them down from engineers needing to use them to people coming from technical and community colleges. That's always been the case that they could do so, but much easier than in 10 years ago. And then the standardization of the actual control systems itself mean that the training is deployable over multiple solutions in multiple cases. So I see robotics and automation, even within aviation, becoming much bigger player as we progress here. It'll be needed to deliver the solutions because we simply don't have the trained personnel to be able to build these things. In maintenance, I see it happening in automated testing.
So the indication would be that there's going to have to be massive investments when we try to retain and get talent in controls and automation engineering.
Yeah. So when we were in Eclipse, we set up a relationship with the community college and set up a standard training program. So we wanted to go from 200 to 600 people, a 400 people addition. We worked through the community college. The pipeline came in, we ran people through the community college for a half a day, and they came to work with us for the second half a day. We built a specific training line to teach them how to build the product. And they worked with leaders who knew the best that we had on the team to help train them. And we moved to a pipeline where we could move 45 or 50 people in a month and then fill in the demand so we could start delivering aircraft quick enough.
Okay, let's concentrate on supply chain here just for a brief moment. I don't think any industry can avoid the supply chain roller coaster. I know CCO has different industries as clients, and we've seen it consistent for the last year and a half, 2 years now, relative to the roller coaster ride that supply chain associates have been on. Aerospace struggles to stay up to date with constantly changing technologies, the advanced technologies, the regulations, and the rising demand. In supply chain, we have seen talent shortages across the board in every industry, rising raw material prices and constraints on getting raw materials, and then extreme part shortages. The MRO sector, especially in aerospace, is taking a hit and impacting the industry very severely. So, Steve, what are your thoughts on how aerospace will embrace automation to mitigate this type of risk going forward?
So in terms of an aircraft structure, ultimately Boeing and Airbus are moving towards automated lines. In terms of building engines, it's still a semi-automated process. In terms of suppliers feeding in at a lower level, the component supplier base, it's still very much full-blown CNC machines, usually 5-axis machines now with multiple flexibility, starting to move on to additive manufacturing so that there's less labor involved. The man-machine ratio can be 1 man to 4 or 8 machines, basically because the systems have some automated activities in between them. Movement of materials from those machines to other areas are then automated through warehouse systems and barcoding and those activities. So I see automation in terms of the manufacturing portion rapidly changing here, along with the fact that the industry is changing and the demand is so much larger now than it was before.
Okay. No one has really escaped the impact of the health crisis, production, and supply chain disruptions. It's been like this for the last several years. Aerospace is indicating now that they will focus on supply chain through dual sourcing of components, multiple validated components, near sourcing, and then a heavy concentration on risk mitigation. Knowing that capacity, forecasting, and planning are critical during these times with increased demand and all of the other issues going on relative to risk mitigation, Steve, how do you think leadership will support these efforts to ensure risk mitigation while demand is increasing so severely?
So risk mitigation itself, all aviation companies that I'm aware of are AS9100 certified, and there are specific actions within AS9100 which define how you structure your organization to minimize risk. Part of it in the supply chain, part of it in the geopolitical issues, which we talked about before, and break them down into tangible and actionable things that we can do. At the last facility we were in Meggitt, we had 21 activities we were tracking for risk. The one I can probably talk about is hurricane mitigation and what we had to do to make sure the facility could now withstand, instead of a Hurricane 1 certification, which was originally certified to, it could handle a Class 3 hit without losing continuity. So the structures in terms of risk mitigation in the organization are embedded in AS 9100, and if you follow the recipe, it leads to logical conclusions on where you need to and what you need to do activities to mitigate your risk.
Okay. I know we've talked some about the talent shortages, but the gap in skill is really causing a gap, not only a gap, but a deficiency in retention and bandwidth of the current staff in aerospace and aviation. Top of the aerospace agenda, and it was mentioned at the Paris Air Show as well, is attracting and retaining the needed talent, especially in the supply chain disciplines, but in this specific industry. Steve, do you think that the widening of this skill gap is going to continue in aerospace due to the technology advancements? Is the skill just not there?
I think the gap is going to continue to widen, particularly while we have so many of these new companies starting up and then moving out of the prototype phase into the early production phase. The demands for skilled labor are going to drive basically salaries through the roof. They've already done it in MRO. Traditionally, MRO, my guess is the MRO, good, talented MRO individuals are looking at 60 to 80% more than they were looking at on a salary basis a few years ago. And it's going to take time for leaders to actually deploy the automation solutions that they need to deploy so that they can still continue to deliver. It's somewhat of a crisis.
And it is. I think that when we look at skill set, bandwidth, retaining the talent, we also have to look at the ability to manage regulations as we go forward with that very same talent. In October of 2022, I believe it was, IATA pushed for a net zero greenhouse gas emissions regulation. And I believe the target was around 2050 that they wanted to be at net zero. So Steve, what will be the impact of this and other regulations on aerospace and aviation as we go forward?
So if you look at the self-declared Airbus activity in terms of net zero by 2035, that's going to hit first. Most of the regional jets will be impacted in some way accordingly. Moving forward, there are some pretty fascinating advanced concepts where the fuselage and the wing merge into a single flatter product, more air resistance. The advances in batteries, and then the need to regulate batteries, because as we all know, the current solutions are prone to some sort of ignition under the wrong circumstances and if they aren't cooled correctly. So, but I think from a regulation perspective, I think the pull through of moving to hydrogen-based engines by 2035 from Airbus is going to impact just about every part of the every organization that's providing anything within aviation. And not so within aerospace. So diversification is probably a good strategy right now.
Okay.
Okay. So, we've talked a lot here about a balanced manufacturing process in a regulated industry. It won't allow the speed of automotive product development. So whereas an automotive vehicle now is changing every 2 or 3 years, the speed of PD for appliances and everything else is a matter of months, if not less than if not just a year. But within this industry, as all these things that we talked about here stack up, we have more time, even though it's more difficult because of the regulated industry, because the type certification and the production certification will really matter here. And then the manufacturing is different itself because it's a slow moving product. So it's more stack charts than MODAPs and industrial engineering and everything else, and then balancing the flow through your equipment and your crane systems more than it is putting in a robotic system and handling it, unless you're dealing with just machining components. And then suppliers will be wobbly as all this happens because there'll be a churn associated with the flush out of the companies that survive and don't survive. So it's really important that organizations spend a lot of time thinking about flexibility, renewed interest in the technical training, and delivering forward. So that's the formal presentation part of our discussion here. Hopefully, we've generated some thought here. This is pretty high level, guys. So we're not getting into the details of industrial engineering or supply chain, and we're just trying to talk about, you know, how this is all going to play out, and the fact that it's literally right around the corner.
Well, thank you, Mary and Steve, for providing us with some ideas on balancing your operations and what that means now. We apologize for Bill's absence, but I'm glad you were able to fill in. So I have a couple of questions for you. I guess probably more Mary. How has the supply chain improved in the past year, and where hasn't it improved?
When I look at supply chain, we see that a clear line of visibility is now the focus. Everything from customer service or demand all the way through distribution. Organizations are really focusing on creating that full line of visibility now. Before it was very siloed, but without that full line of visibility, they're unable to be flexible and they're unable to meet the demand. I would say that early risk assessment is also a key focus. They have found that risk mitigation is going to be critical to meet not only the technology challenges, but also the increasing demand. So we have had several clients come forward with the request for risk mitigation assessments, which are really on-site assessments that organizations are now doing to get what we refer to as master file integrity. And that is really to understand their capability, their capacity, and their quality standards, including manning. All right, we've talked a lot about, you know, the gap in talent, but it goes all the way through supply chain as well. So I would say that their focus on that has improved. I would say there's probably a few things that have not improved, right? And that's the cash burn on inventory. The cash burn on inventory continues. It's the wrong inventory. Suppliers are unable to be flexible enough to meet demand. And the problem with that is the demand is there, but the build schedule is fluctuating so much that they just can't keep up with it. So the volatility is just creating fluctuation throughout the whole supply chain. So when you look at cash burn and you look at those that own P&Ls relative to companies, you know, supply chain is getting a true new focus of I have to control the cash burn. I have to make sure my revenue is getting out the door. And with the part shortages, that's a challenge, right? So we're still seeing revenue, cash flow, inventory issues, and the inability to be flexible enough to rotate around the build schedule versus demand.
Mary, you've also got the issue, which we've started to see, is that the lower tiers of the supply chain are not as well managed, let me say, as the higher tiers. So Mary's recently gone into an OE company that directed her to a tier one supplier to try and support the system. And by the time Mary finished, she was in tier three and tier four suppliers, because it wasn't the tier one or tier two that was causing the problem. It was at the lower level of the system, getting down to the mom and pop shops that still support a lot of legacy components and products and drive the business.
Okay, Steve, you sort of answered one of the questions. I think it was probably for Mary, but where are the main bottlenecks and weak spots now? Is it in? I don't want to give you lead your answer, but what are the continuing bottlenecks?
The bottlenecks in supply chain or in technology?
In supply chain.
We are still seeing post-COVID, we have shipping constraints. We have massive part shortages. I don't think any of that has changed. I think that I know from my perspective, when I get in with a client and they say, even though COVID is behind us, and I always say, stop right there. If you're in supply chain, COVID is definitely not behind us. Those constraints that we've seen over the last year continue, and they continue very forcefully. They're impacting the shipping regulations, the ability to get product. It's putting a new focus on sourcing locally, and then also, as I had spoke about earlier, dual sourcing. The bottlenecks, when you look at tier twos and tier threes, are what Steve really referred to. They are really struggling with trying to keep up with the switching build schedules, and they no longer have the right resources. The talent just isn't there.
They lost about, Eric, they lost about 50% of their most talented people through COVID. So they're still recovering to train people to get themselves back up to the same level they were 2 or 3 years ago.
Mary, you talked about inventories. Is there any magic formula on trying to predict and how much to have? You talked about the cash burn and all these things that face smaller companies. I know there's probably no royal road to success there, but is there any advice you can give?
Definitely there is. And this is what I tell several of my clients that are going through this situation currently. Demand management, planning, and inventory all have to talk to each other. That goes back to creating that full line of visibility. If you do not have all three of them in sync, speaking to each other and managing the demand versus the build schedule and part availability, you will never get out of the cash burn. A lot of clients right now are getting in materials that they don't need, that they can't manage the build schedule because one or two other parts are missing, right? So really it's not a formula. It's clear transparency, cross-functional communication, ensuring that your demand, planning, and scheduling are all linked together.
Right. You mentioned risk. What part does cybersecurity play in that? I know there are increasingly stringent regulations on what sort of hoops you need to jump through for cybersecurity. Could you talk about that for a little bit?
I can tell you as part of our risk assessments now, we have what we call a self-assessment that we send out to the supplier so that they can give us what they think they do well and not so well. But our on-site assessments do cover all of the cybersecurity. We have had several of our clients hacked, crashed their entire ERP and MRP systems, inability to get out emails. So we assess that now in advance in the hopes of making sure that they have systems and firewalls in place to ensure that if they do get hacked, that if they have enough firewalls or at least a backup plan to be able to manage the business going forward. It's a huge concern right now. It is global. I will tell you that we have several smaller clients that are very concerned and taking the time as well as the money to invest to make sure that they are protected. And I think that's a really strong sign when smaller companies like that understand that risk and they're willing to invest to protect their business.
Okay. Steve, you mentioned sustainability, and that has been a buzzword at both Farnborough last year and the Paris Air Show this year. And there is obviously a greater need for the supply chain to get on board with the manufacturer's net carbon zero goals. What are the first steps for smaller companies?
I think they need to develop understanding of which portions of it reflect their business. From a societal perspective, power and utility generation, how it comes into their facility. A lot of companies, surprising me, are in the US are working to try and understand that. But if you're providing a component for an aviation valve, for example, as a small company, you will find that the solution for those valves are about to change. So staying up in touch with the technology, working with the company that you're providing into is critical. Understanding where the strategic direction is going so that you can be a partner to that direction. Trying to take advantage of some of the newer companies. There's risk associated with a lot of these newer companies, right? So, but the move towards how do we store hydrogen? How do we manage hydrogen as an energy source? If that's the way we're going, the move towards sustainable, recyclable fuels, or fuels from organic products. It's quite important that you stay up to date on these activities, but recognize that a good supplier into the aviation industry has the chance now to grow as the industry grows itself. So stay close to your OE company and look for where their demand is changing. If you're an equipment provider, providing that investing in people is really a key issue, because the technologies for building a rocket aren't about to substantially change in the future. For example, if you're a small provider of components into an aviation company, starting to get into additive manufacturing so that you understand the products that are there, because a lot of the composite products that were traditionally made were made based upon metal products, and the actual composite manufacturing process itself was very difficult to regenerate that metal product in a composite form and then get that certified. Moving towards additive manufacturing in that area will be key for them going forward. Control systems, understanding where control systems are going, and understanding, getting a stable and predictable supply for your control systems, because there will be far more measurements required in the future on these parts, because we'll be making so many more parts, and the old manual quality inspector process won't function. Poka-yoke systems during your manufacturing process. I've said a lot, but you see, it's basically the common theme is understanding where the technology is going, understanding where your OE company that you're working with is going with that technology, and working with them and then delivering solutions to them, because they can't do it all themselves. So they're ready for people to step up.
Thank you. Very, very good points to make. On the topic of regulations, what are the most important ones that are coming up that manufacturers in the supply chain need to pay attention to?
So I think the biggest thing is the automotive industry and the aviation industry is starting to connect in terms of the volumes are increasing so much. If you look at some of the eVTOL numbers coming out, in roughly 10 years, they expect 100,000 eVTOL systems out there. If you listen to some of the predictions that are out there, that's 10,000 a year. That's a huge number from an aviation perspective. So adopting some of the automotive practices like APQP, Advanced Quality Product Control, which is a whole system for delivering an automotive vehicle, and then tailoring it so that it meets the regulation requirements for FAA certification, for either type certification or production certification. Designing your production system so that you allow some flexibility for continuous improvement. We went into one unfortunate company recently that had put in an ERP system and broken their routers up into small little segments and defined and established a production certification back given that criteria. We had to go in and go through production certification again for that supplier, with the routers open from the beginning to the end, so that we could move things around and provide some continuous improvement. And that led to a dramatic increase in production for them. So it was worth doing. But there are like tips and tricks all over the place that you can just, from a regulation perspective, you can get yourself into trouble if you don't think through systemically and the digital thread all the way through to delivery of the product.
All right. You talked a little bit about automation and some of the other things that were reshaping the supply chain. On what should a smaller shop prioritize capital expenditures? You talked about measurement. You talked about automation. Is there any first step there to take?
So if you're delivering kind of a widget, then your focus should be on delivering that quicker and less expensively and larger volume, but very safely. If you're delivering a component or a subsystem, and that's the way it's going, honestly, automated test is the area to focus your effort on, and understanding how to recover from a failed test. First time yield in aviation historically is in numbers an order of magnitude worse than in the automotive industry, for example. So focusing on ensuring that your product, its tolerances, your build technique, and your measurement process through to test is the most important thing. Because in my experience, And anyone who's been in an aviation plant will tell you, you walk in and you see the pile of product trying to get through test. So for a small shop, it may seem counterintuitive because they're there to make the product, but making sure that you can test it and qualify it is absolutely critical.
So
All
just
right.
on that as well, Eric, one of the things that we're seeing in supply chain too, especially with smaller organizations, is they are trying now to automate their demand management. In the past, they've been unable to do that. They didn't want to invest the money in all the systems and a solid ERP, understanding how they could get EDI and things like that from their customer and to their customer. Right now, there's a new focus from smaller organizations because they feel they will be more flexible if they go ahead and do the investment and do the automation in the production schedule and demand systems. So with that also then comes, you need people to know how to run that. So I think that when you look at what the smaller organizations are investing in, it really will be a focus on supply chain and automation in their demand and planning organizations.
All right. To follow up with that, one of the hot topics is artificial intelligence to help streamline some of all the processes from order intake to delivery. Do you see that as an opportunity or a challenge not worth taking at this point for the smaller companies?
So let me take that, Mary. If you look at plan, order, source, engineer, make, deliver, return, I think the plan, order, source portion is going to be significantly impacted by AI. I think the delivery and return aspects will be hugely affected on it. But basically, manufacturing is a people process. And I see that being less impacted, although I see automated documentation becoming something much better there. Okay, over to you, Mary.
Yeah, no, I agree. I agree with Steve. He makes some good points there.
Okay. Steve, you talked about some success with the training pipeline. Are there lessons there for smaller suppliers, and what would those be?
So a local community college will be absolutely delighted to work with a smaller supplier. And whatever part of the geography you're in the world, it's equivalent. These organizations have advanced a lot in the last 15 years. They've spent a lot on technology. They spent a lot on remote learning, but ultimately you have to get and make a product. So for people within MRO, partnering and you're looking at an aviation technician certification, for example, partnering up with a company so that they can get an internship with that company and opening up your company to interns and bringing in that pipeline is critical because, the drop-off rate of students is still pretty high, but when you bring them actually into a company and they actually see how their talents are going to be used and how it helps them provide for themselves and their future, that becomes a key thing. So don't be shy about being a small 8 to 10 person shop and reaching out to the local community college and saying, I'd like an intern. They'll go with you.
Same thing in supply chain, Eric, is these smaller community colleges are willing to give you interns any time of the year. It helps not only the students, but it gives visibility into the college on what the requirements of the future are going to be. It helps adjunct professors understand the needs and requirements going forward so that they can create the syllabuses and make the college even better, right? As the talent and the skill set needs to change. But some of these interns, I will tell you, we just had an opportunity to bring an intern into a current client. And when I talk about automating demand, literally this intern could do it better than anybody sitting at the desk. And it's because, they're used to it. They're a younger crowd and just thrilled that he could actually help the company. And the company, again, makes him a job offer that says, when you're done, we want you to come back. It's all very positive with these colleges.
And then in high schools, Caterpillar, Eric, have had a history of as their equipment becomes obsolete and it doesn't meet production requirements, but it can still function. For years, they've been taking small machining systems, welding systems, and giving them to local high schools so that the local high school training program starts to build up a pipeline of individuals and supporting them by taking them through their plants and facilities. And that's a huge part of Caterpillar's success is they built their own pipeline for. I mean, they've been doing this for generations, and they're at the stage now where they're offering 3-axis CNC machines into the colleges. They don't need them. They don't want them. They want to move to 5-axis and more flexibility in robotic installation. They're putting in small robot systems that are now obsolete. They're not the same ones they had 10 years ago, so the control systems are hard. The high schools will talk to you too.
All right. Excellent suggestions. We talked about the electric vertical takeoff and landing, or eVTOL market. Is there a growing or separate marketplace for parts that the supply chain should be involved in or paying attention to?
So they all get batteries from the same place. So that outside of batteries, I think from an aviation perspective, the eVTOL supplier OEMs should be looking at automotive suppliers and seeing if they can partner up. There's huge advantages there. The volumes are going to be larger, so it kind of lends itself to working together. And the traditional suppliers are looking to diversify because so I may be more of a Jetson fanatic than the other average person. But I see 10 years from now, people having personal mobility vehicles in the automotive industry starting to wane a little in terms of its importance in society. And maybe it's 15, 20 years, but so getting ahead of that is important.
All right. So sort of to follow up on that, with the new aircraft coming along, we'll still have large fleets of traditional aircraft. So how much should a supplier divide their attention or resources on focusing on these new technologies in the next 5 to 10 years with their immediate needs in the next 5 to 10 years?
So that's a tough question because the dynamics are changing really quickly. So if you'd have asked me this 2 or 3 weeks ago before India released the large order for seaplanes, I would have said that just bank on the business is going to be there. It's going to move to the growth markets of India, China, South America, where the demographics are all helping you. But now those emerging countries are doing what China did with cell phones, where they moved away from landlines and straight to cell systems. So I don't think the path is clear yet on what to do. Yeah, you have to keep providing legacy product, and I don't see legacy product going away very shortly. But I would look at your demand line out in the future years, and I would run scenarios estimating what happens when the demand drops on something, and how do I, am I better off now doing a last time build and spanking it and stocking it and recognizing that I can bring it back up again later on, and how do I do that? I would be asking myself those questions now.
All right. You mentioned diversify in one of your comments. Should a smaller company look to the burgeoning commercial space market? Did you imply that as part of diversifying, or were you thinking of something else?
So diversify within the portfolio of aviation. So you've got your legacy OEMs and your legacy tier ones and your tier twos, and they consolidated the tier ones, but the tier twos, there's still thousands of them. So diversify with respect to that, but also diversify within the new product. So make a decision. Are you going to work on eVTOL? Do you have something to offer automotive changes? I mean, Ford has gone all in on vehicles. The technologies are very, very similar for an eVTOL system as for an automobile vehicle, an autonomous automobile vehicle, right? So they're very, very similar. So start stretching out and look at other transportation modes. It'll be really interesting to see what happens with rail as all of this happens, and how it works with autonomous vehicles and how that whole demand equation, works together with each other.
All right, Mary, with the topic of reshoring, will that help tighten supply chains in the near future, or is that more of a 5 years and beyond effect?
Oh, no, it is definitely near. We have several organizations that we're working with to help them reshore and nearshore. They are actively going out and requoting all of their content. It is part of their risk mitigation strategy. It comes from the CFO as well as the CEOs of most organizations of we have to mitigate this risk. And it also folds right into dual sourcing. In the past, dual sourcing was always very cumbersome. A lot of engineers said, well, we already have a supplier, don't want to have to validate another supplier. Now it's mandatory. They want that risk mitigated. It is a immediate need and immediate focus across all the industries that we're currently working with.
I saw a McKinsey article probably 6 weeks ago, which says there are 4,000 US large company-based suppliers who are looking at nearshoring.
That's a pretty impressive number there. So I think we have time for one more question. So how is the war in Ukraine disrupting the supply chain, especially relating to raw materials such as titanium?
Well, I will only briefly talk about that. First of all, I think raw material pricing and raw material constraints are across the board in all the industries. Of course, heavy in aerospace, aviation, automotive, commercial truck. I will tell you that the constraints will continue as the war continues. There are abilities to get product, but that product is very constrained and very much in high demand. And so it's causing a lot of volatility in pricing. It's causing a lot of volatility in the ability to have the supply meet the demand requirements. Organizations that are exposed to it are trying to get Plan B. Plan B is not easy to come up with right now. So they are definitely constrained, and it's definitely impacting the industries.
Thank you. I do have one more question for Steve. And the slide, one of the acronyms was capital M, small x. Is that for manufacturing
Mexico,
excellence?
sorry.
Oh, Mexico? Okay. All right. Fits right in with the reshoring. So, well, we're just about out of time. So thank you, Mary and Steve. Thank you again to our Manufacturing Group webinar series sponsors, ISCAR and Renishaw, and this webinar sponsors, FPT, SMW Autoblock, and Tata Technologies. On behalf of Aerospace Manufacturing Design, I wish you a good day and goodbye for now. Thank you.
Thank you, Eric.
Thank you, everyone.
You can find more Manufacturing Matters plus the MFG Radio Network's other podcasts on Apple Music, Spotify, Google Podcast, or on our websites at todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, and evdesignandmanufacturing.com.